Hello and welcome to this flipped instructional session on Unit 1, Lesson 8, Weather Fronts. We're going to be taking a look at our weather fronts today. So let's jump into our lesson, and before we read this introduction, remember to click that Lesson Resources tab on your first screen so that you can open up your objectives as well as your student guide. So our objectives for this lesson are to describe how air masses interact at cold, warm, stationary, and occluded fronts. Make sure you're taking notes on all of those, and then describe typical weather details associated with each of those fronts. Also, don't forget, this is where we get our student guide, so we're going to go ahead and click on the student guide for this lesson, and we'll refer to that student guide when the lesson tells us to. The student guide gives you those objectives as well as some of our materials, keywords, and then it will give us the activities that we need to complete. So let's read our introduction. Weather fronts. Has this ever happened to you while doing schoolwork? And this just makes me laugh because if you're sitting outside and all of a sudden the weather changes that drastically, that's pretty crazy. But if it has happened to you, then we want to pay attention to this lesson, find out what kinds of weather different air masses bring, and then the next time you'll be prepared for sudden snowstorms. Hopefully you're not sitting outside doing your schoolwork like this guy here, and he's already dressed rather warmly, so maybe he knew that a sudden snowstorm was coming. All right, so it says use this table to organize what you learn about fronts. Be sure to include words as well as pictures, and it is very important that for this lesson that you're using those pictures and so forth, and a graphic organizer is a great tool to be able to do that. So let's go ahead and open up that graphic organizer and take a look at it. And here you can see it's listing each of the fronts. How do these air masses interact? What kind of weather is going to be produced from those weather fronts? And so this is a great graphic organizer for this lesson. Make sure you print that out and take notes on it. We're going to do a quick review of air masses. In a previous lesson, we learned about the 5 types of air masses that affect our weather. So review those air masses. Remember that depending on where the air mass forms, that's going to determine what kind of air is there. If it's warm and dry, if it's humid, cold and dry, or extremely cold and dry. So go ahead and review your air masses. Make sure that you can match up each air mass with what type of air you are going to find in that air mass. So once the air masses form, so if they form over the ocean, they're going to be wet. If they form over the continent, they're going to be dry. So once those air masses are formed, then they move. And when air masses meet, that is where we have weather fronts. That is where we have weather occurring, is when 2 air masses meet. So if 2 air masses with different temperatures or humidity levels meet, they do not immediately mix or blend. Instead, a line or boundary forms between them, and this boundary is called a front. Go ahead and watch the video on this page about storm clouds. It just shows you how these storm clouds form. Now, let's talk about each of these fronts. A warm front. If a warm or more humid air presses forward and colder and drier air draws back, the boundary is called a warm front. So what's going to happen in a warm front is the warm air is going to rise above the cold air. Because cold air is more dense, warm air is not as dense. So it is going to gently rise above the cold air. As it rises and the air then cools off, it's going to condense and form clouds. So what type of weather are we going to have at a warm front? We are going to have some drizzly rain. Warm air is going to rise above that cooler air because it's less dense and cool, and the moisture in the warm air will form clouds and then fall as precipitation. You can watch the video here of that forming. Clouds at a warm front, we are going to have some cirrus clouds. When a warm front moves in, it's going to produce nimbostratus, stratus, and cirrus clouds. Cirrus clouds, like the ones pictured, are formed when warm air gets cold enough for water vapor to form ice crystals. Cirrus clouds appear as those thin and wispy clouds. Now let's see what happens when a cold front pushes in. If cold or drier air presses forward and that warmer or more humid air is going to draw back. So what's going to happen when this cold front moves in is this cold air, remember it's more dense, it is going to kind of dive in underneath this warm air and push it up, but it is going to push it up abruptly. So kind of opposite of our warm front, that warm air is gently rising up. In a cold front, when that cold air pushes in underneath, it's going to push that warm air up abruptly. And that is going to cause some extreme weather. This is where we're going to get our storms. Cold air is denser, pushes in quickly under that warm air. That warm air cools to its dew point, forming clouds. Cold fronts bring dramatic weather, like your thunderstorms. What kind of clouds are we going to see at a cold front? We're going to see some huge cumulonimbus clouds, which are commonly known as your thunder clouds. So if you see these, you better get inside. You may see a thunderstorm with heavy rain or lightning, which can be dangerous. So watch the video of the cold front. And then, is the front cold or warm? Can you connect the characteristics of a front with the type of front? So warm or cold? So cumulonimbus clouds form at which type of front? I hope you remember that is your cold front. So I don't know how you shoot your basketball in there. Oh, you pick it up and put it in. All right, and then you can reveal those answers. So practice determining if it is a warm or cold front. We're going to move to our stationary front. A stationary front is when these two air masses are moving towards each other. So one thing to take note of in your cold air is this, they're moving in kind of in the same direction. It's going to push underneath these. In your stationary front, they're moving towards one another, okay? So when a cold air mass and a warm air mass meet, they come to a standstill. This boundary is a stationary front. Again, you're going to have that cold air and warm air. When they meet, they kind of battle for supremacy here. Who's going to win out? Warm air is still going to rise and produce a cloud and some weather, but a stationary front, you're going to have some rain. It's going to last a long time at a stationary front. So at a stationary front, you're going to see gray skies, rain, or snowy weather that may last a long time. All right, and then our last one is an occluded front. So sometimes an occluded front is you've got two air masses moving in the same direction, and they're going to kind of zip together and trap some warm air in between those, okay? So a warm air mass can get caught between two cold fronts. So it's like these two cold fronts are moving in the same direction. One finally catches up with the other, and it's like they zip together and trap that warm air in there in a wedge shape. And this forms a single occluded front. But in an occluded front, there are clear divisions between the cold air, the cool air, and the warm air. As with other fronts, when warm air is forced up, it's going to cool. You're going to have water vapor, the air liquid, and causes light to heavy precipitation that can last a long time. So you're going to have long precipitation, but it's going to be a little bit heavier than in your stationary front. All right, and then you can play stationary or occluded front. Practice noticing the difference between these two types of fronts. Now, we've learned about all the different types of air types. We've learned about the different kinds of fronts. But a couple of other things. High or high pressure areas bring fair weather. Low or low pressure areas are going to bring wet weather. Always remember that. High pressure means usually clear and sunny. Low pressure is where you're going to get your rain or wet weather. It is important to know, make sure that's in your notes right there, that high, clear and pleasant weather, low, wet weather, high humidity, or both. It's important to know the difference between weather that comes with high or low pressure system and weather that comes with fronts. So in the southeast, a cold front shown as a line of blue arrows. So this is showing your cold front coming in. Okay, and these little triangles are pointing in the direction that the front is moving. So in the southeast, the cold front shown with blue arrows will soon move into a high pressure area. As you can see, here's a cold front. It's moving towards this H. This is showing us high pressure. And then these red right here, these are warm front areas, and they're moving in the opposite direction of this cold front. All right, and then you've got your images here, the fronts, how the air masses interact. Remember, we talked about what happens to the cold air, what happens to the warm air, how does it move? Does it move slow, abrupt? Is it trapped? So make sure you're telling how those air masses interact and what kind of weather they produce. This is what you're going to put in your graphic organizer. All right, then you have check your knowledge. So just review all of that information. And then you can come to the flip follow-up for further review on your weather fronts. So I will see you on the flip side. Look for a flip follow-up session in your Class Connect schedule. Attend that session. We'll carry this topic as well as others into further practice. You can ask any questions you have on any of those activities. Attend a help lab for additional support. Have fun, and I'll see you soon.